Please welcome to the headline stage, Foundation, with Sankeat Pathak and Chris O'Connor.
All right, good morning, everyone. My name is Chris O'Connor. I'm a defense and deep tech investor, and I'm excited to kick off this portion of the conference with what I know will be an incredibly interesting discussion about robotics, more specifically humanoid robotics, and what role they might play in bringing about the future that we heard Chris Power, the founders of this conference, and others really share with us this morning just a few minutes ago in the kickoff session. And so a big honor for me to be up here with Sankeat, who is the CEO and founder of Foundation. Before we get into some questions, I think we need a little bit of an explanation because we have a special guest with us today. So tell us a little bit about what inspired you to build Foundation and what we're looking at here.
Yeah, for sure. So as you can probably guess, we're a humanoid robotics company. The goal with Foundation is essentially to be able to automate all kinds of labor. So we're currently targeting factories, warehouse, defense applications. The whole impetus of the company is we are at a place now where you have by and large a lot of the hardware quite reliable and stable. So all compute's available, cameras are available, electrical ECUs, and all of them are significantly better than they were like a decade ago. And now you finally have enough breakthroughs on the AI side to be able to build what we call end-to-end policies, be able to train these robots to essentially do a task autonomously without actually requiring a human behind the scenes. So it's kind of the right time, and we also think if we actually want to increase our overall manufacturing output, and in case of the US, reindustrialize America, we need automation, because otherwise we're not going to be able to build a lot of stuff in the US.
Yeah, and I want to kind of dive right into one of the interesting topics that I wanted to discuss with you, because I think you're kind of maybe unique in looking at this application, but there's a tremendous momentum happening around rebuilding our defense industrial base from the startup community, from the capital community, from government. You're looking at the military use case as one of the early use cases for the robot. Can you talk a little bit about why you're looking at that as a use case, and maybe talk about some of the applications you've started to uncover?
Yeah, for sure. So just for framing, most of the warfare in last few decades have increasingly become automated. Turkey today, I believe, is the largest manufacturer of weapons drones. And that has clearly given a lot of people just completely unfair advantage. So US has to, in this scenario, catch up and essentially automate as much of the defense work as we can. The goal with Phantom, which is our robot, is to be able to do that on the ground, while Andrew and other companies are working on defense to the air. And we think it's quite crucial, because otherwise you're going to have disproportionate loss of life on one side, and you want to be able to avoid that. So I do see the future where you have most of the warfare just automated on land and in air, and also in sea. The current use cases, we've done some work with the US Air Force and Navy. A lot of work is currently around inspection, repairs, things like that. So being able to essentially take work like drone maintenance out of the hands of soldiers. Next few applications we have start going into the active battlefield, primarily to be able to scout the enemy and be able to kind of be the first body in. So those are the use cases we're focused on in the short term, but in the long term, I do think it takes shape of full automation.
There's interesting discussions going on, not just maybe around humanoids, but other autonomous applications in terms of what a human should or should not be in the loop for, or what jobs should be inherently human versus potentially robotic or automated. How are you thinking about that as you're looking at some of these early applications and having discussions maybe with Department of Defense? Is that coming up? Are there things that you're discovering where maybe this is best suited for, not best suited for, and a human should sort of do that role? How are those discussions happening?
Yeah, I mean, I think generally on principle, the idea is anything that humans don't want to do, you want machines to do. And having a humanoid form factor makes it so you can interact with the world the way humans do it. So we do think this is probably the most scalable form factor. As it comes to the military specifically, based on all the conversations we've had, it seems like the military, if for all of the back office work, so all the inspection, repair, full autonomy is actually quite enticing. When it comes to the battlefield, it's actually teleoperation that is more enticing, because they do want a human in the loop making all the judgment calls, which I believe is a good idea. But that's how it's splitting up right now.
Okay, fascinating. And because we're here in the heart of Motor City, let's talk a little bit about maybe automotive and other industrial sectors where we could potentially see Phantom playing a huge role there. What are some of the other interesting applications that you're already finding use cases for and starting to work on?
Yeah, so on the military side, we work with the Navy and Air Force. On the enterprise commercial side, we work with auto manufacturers, consumer goods manufacturers. As of last month, we did our first deployment at an auto manufacturing facility where the robot's actually doing real work. Our goal this week is to try to get it to do full shifts. So if we achieve that, that would be probably a huge breakthrough, and we'd be the first company in the world who would have done it, first humanoid company. We are above the industry standards on kind of like OEE, which is overall equipment effectiveness. We've gone as high up as like 95%, averaging about like 87%. And we think that is, I believe that's also, Foundation is the first company that's crossed that mark. So right now we're laser focused on making sure we kind of maintain this high OEE through the full shift. And in this case, the work it's doing is something called cladding. So you have a car part comes down the conveyor belt, you pick it up, you label it, you QC it. Then if the QC succeeds, you essentially put it in a rack. If the QC fails, you discard it. And once you fill the rack, a human comes with a crane, picks it up, and kind of like takes it back and gives you another. So there's a lot of work. About 50% of the workforce in auto manufacturing facility does not work on final assembly. They actually work on what's called kitting, so all the work around final assembly. And our goal in the short term is all of the work that happens in kitting is by and large very repetitive, boring, mundane, close to 100% turnover rates if you look at 24, 36-month time horizons. And our goal is just to be able to take that over. So as humans leave, you have these robots taking over. You'd still have humans in the loop, but more so supervisors than actually the line workers.
Yeah, and correct me if I'm wrong, but I think what's kind of interesting is by using a humanoid form factor, you enable companies to use their existing lines rather than rebuild a line around a non-humanoid type of robotic application?
Yeah. So I do think, without being too dramatic about it, I think this is like sincerely the case. We only have 30 years to be able to automate most of our manufacturing. Because we already have declining birth rates. In the next 30 years, we won't have enough young people actually wanting to join the labor force. That risks humanity to just regress back because you won't be able to produce enough goods and materials. So by definition, you have to automate all of the stuff. It's unrealistic to expect these things to be automated if you also have to change the factory floor significantly. So if you really want to achieve that 30-year time window, the only way you can do that is if you don't expect anything in the factory to change. Yeah. Which essentially is the goal with Foundation.
I love that insight. And maybe now digging into some of the technical aspects, because I think what blows my mind a little bit is this was built in 14 months from company start to what we're seeing here next to the stage. Talk a little bit about some of the technical things that you've had to overcome in that period of time to get to this in such a short period, and kind of maybe where you see the near-term horizon of new technical challenges that you're working on right now.
I mean, yeah, to be able to do like a reliable humanoid, one of the biggest things you have to solve for is just build quality and reliability. Second big thing is just overheating. So a lot of the actuators with, for instance, some of our competitors, they end up overheating, so the robot could barely have an uptime of an hour or something. We've just made inherently like different architectural choices where we have less heat dissipation on the actuator. Actuators are those motors that sit on the robot. The motor and the gearbox makes the robot move. That piece has been a big unlock. So like the team's done a phenomenal job building like a pretty low friction gearbox that does not overheat, extremely efficient, which means requires less energy as well and can lift more. So we can lift twice on an average to what our competitors can. But that's like one of the big unlocks. The second piece is being able to do autonomy with less data. And currently almost all of the approaches people have are pretty much copycats of like ChatGPT and LLMs. So what they're really trying to do is they're trying to input all the sensor data and predict action tokens. Very similar to with ChatGPT, it's a prompt, you give it a prompt and it predicts what comes after the prompt. As you can already tell with ChatGPT, there are a lot of hallucinations, and you cannot afford hallucinations in the real world. And that's with like all of the data of the internet. So it's not even like just a little bit. So most of the companies have started adding reinforcement learning on top of it that looks at the work of a bunch of agents and then decides, okay, what's accurate, what's not a hallucination, and pass it. The issue with robotics, especially manipulation in robotics, not really locomotion, is that every single task you do has a different thing you want to reward. So the way reinforcement learning works is you have to explicitly define reward functions, which is praise the bot when it does X, just essentially discourage if it does Y. So for walking, it is stand and not fall, walk and not fall, like all these different things. So like you have pretty straightforward reward functions. You have to define, and again, like those are some that I'm saying from the top of my head. Most of the stable reinforcement learning based locomotion has tons of tedious work that is just about discovering the reward functions and figuring out what really works and fine tuning it. If you do that task by task, again, you cannot automate this in 30 years. So our team essentially, and again, this people even before Foundation and the team, they essentially invented this new model architecture, which is called deep variational Bayes filters. So it kind of works like a deep learning model where it takes a lot of the data that's labeled and then tries to build pretty much like a spatial model that can predict physics, dynamics, kinematics of the task space and the real world. What that really enables you to do is it enables you to be able to build this reasoning layer that sits on top of these action models. And now anytime the action model wants to perform an action, it reasons through the reasoning layer. But now we can train this reasoning layer pretty much quite rapidly for new tasks. It's a function of collecting some data, versus reinforcement learning is a function of tedious reward function discovery. So we do think this is probably a better path. That's another reason why we've been able to kind of like get to the 87, 89% OEE. It's primarily because the underlying model architecture is quite different to what everybody else is doing, and it's actually quite helpful in being able to train repetitive automation for specific tasks with very, very little data. And obviously, like it scales quite well. So like the Power law still applies. You give it more data, it becomes more generalizable and can do more things.
And you're mentioning gearboxes, maybe different approach to teaching the robot. Are there other things that you're building in-house versus working with others to integrate? I'm specifically maybe looking at the dexterity in the hands and other things. Is that in-house functioning that you're building? Or?
Yeah, so pretty much the whole robot's designed at Foundation. Actuators, all of the mechanics, everything. Obviously, we don't build our own sensors, so we don't build our own cameras. We like technically also don't machine the parts yet. We're going to start doing it in the next couple of months. Our goal is to machine majority of the parts in-house. But then all of the design is Foundation's. The current hands are quite limiting. Like they can only go up and down like this. It doesn't have the same human dexterity, so it doesn't have abduction. And we think that is really needed to be able to interact with the world the way humans do it. The true test of when you have good hands is if it can just do this. If it can open up a water bottle like that, then you have good hands, because it essentially accounts for two big things. One, you have enough torque, so you have enough force in your fingers, because obviously the robot seems like it has enough force generally, but doesn't have enough in its fingers, because all of its actuators are sitting here in the palm, so they're pretty small. So you have to move all of those back into the forearm, and essentially be able to then, like a puppet, move your hand, just like how humans do through the carpal tunnel. And then you have two things. One, you have enough dexterity to be able to move things like humans. Second, you have enough torque to be able to do it. So I think these hands are like quite rudimentary and are good for like pick and place type applications, but not really manipulation. So one of the big works we'll do between now and like all through next year is the second generation of hands that have more dexterity and more torque.
I love that. And I want to get into some of maybe the societal issues around robotics and humanoids specifically, but the investor in me has to ask, what is the business model for this? Do you envision selling individual robots? Do you envision some sort of SaaS version of this? How does this work in your mind?
Yeah, I think of Foundation as like pretty much like a labor company, and we're selling labor at a cheaper price and at higher efficiency. So we rent our robots, and we rent them at a cheaper price than it would be to rent it, like essentially get a human to do that job. I I suspect that is going to be the model for the foreseeable future, because if you really want these robots to become more and more useful, which is you're constantly collecting data and training more tasks, specifically in the paradigm of defense, manufacturing, things like that, you do need some kind of recurring incentive mechanism to be able to do it. With consumers, it's different. You can pretty much like buy stuff once, and then like you want to make the product better because people keep on pretty much have like a high replacement rate. But in factories and warehouses and even defense, we think the right model is just rent.
Makes sense. And maybe talking on some of the societal issues here, I'm curious, what sort of things do you have to contend with that might be unique to developing a robot in humanoid form versus other robotic applications, which frankly are all around us? They're just sort of hiding in plain sight. Whereas this is something that very much to us maybe has an emotional reaction, or how does that come up in the work that you're doing at all?
So I was actually bracing for that. I thought that there would be an adverse reaction to robots. The most common thing we see is people walk up to them and want to take pictures with them. So as of now, it seems
we
like
all love
humans,
a good selfie, right?
Yeah. As of now, humans love them. I'm sure there are going to be tensions. Like I wouldn't pretend that at some point we would not fall in this kind of like interim state where robots are doing majority of the work and the unemployment rate's high, but you don't have a mechanism to be able to give people a good quality of life. I hope that doesn't happen. I hope even before that we figure out what's kind of like the updated purpose. Because historically, like, and most people you'll talk to, they don't really love their job. Like maybe this room's different because we're working on things we really love. Most people don't feel that way. But we've had to practically force people to work, because otherwise we would not have any progress. We wouldn't have any of these buildings or anything. So, and the best and the most sadistic way to make people work is by saying, if you're going to work, you can eat food and have a roof to kind of like sleep under. In the absence of that forcing function, which is you don't actually need humans to go and start building a factory or start building a building, something changes. And I think people would be happier for it, but definitely there's this risk that there's an overlapping period where like humans kind of like don't have enough other jobs. The alternative to that also is, like if you look at how many employees Henry Ford had when he started the assembly line, it's significantly lower to what Tesla has. And primarily because with more automation, the cost of goods comes down, and then your overall addressable market gets significantly bigger. So the optimist in me hopes that at the core of it, what happens is about the same or more people get employed. It's just the markets for a lot of the products and goods get much, much bigger because the cost comes down significantly.
Yeah, I share that optimism with you. I kind of hope that that's where we end up. And we've got a little bit more time, so two more final questions, if you don't mind. So are you, I sense this is a yes, but are you optimistic about humanoids becoming a part of our everyday life beyond just industrial applications? Where do you see maybe that transition potentially taking shape?
Yeah, I think we're probably a few years away from having these robots do some form of work at home. So it could be that they come in temporarily and like you had a party and they're going to clean up the house, or your kids are not cleaning their room and you're going to call a robot to clean their room. So I do think we're going to start seeing use cases like that. The piece that I hope we don't see is go walk my dog and babysit my kid, which is like things that make us human. If you kind of like take those things away, then that's kind of like a Wall-E type future. So I hope that doesn't happen, but there's tons of stuff that people, if we could just free up people's time, they would spend it like in things that they enjoy far more. Yeah. And I do think that's happening in the short term.
Yeah, I love that vision. And final question, just a brief prediction. 5 years from now, what does Foundation look like? Where are your robots? Are there different robots? What do you think?
I hope we have robots on the moon. So nice. I think 5 years from now, I'd be very surprised if you don't have millions of robots just around. Now, my sense of, does that mean in factory, warehouses, or homes? I believe the majority of the robots in the next 5 years would be in factories and warehouses, and there would be an early adopter market for homes. and the cost has to come down significantly. I think like the cost has to go down pretty much like 1/10 before it becomes, I think, like a mass consumer product.
Yeah.
And also you need that much data to be able to get it there.
Yeah, well, you're making it happen. I mean, 14 months and this is what we have, so it's incredibly impressive what you and the team have done. Congratulations on the progress so far, and thank you so much for sharing your journey with us.
Yeah, thank you.